So when I saw you on Monday, we learned how to calculate molarity or concentration of solutions. So today we're going to learn, well, how do we dilute those? Because most of the time, we just buy one concentration of a solution, and then it's cheaper to just dilute it to the concentration that you need it, okay? Rather than just buy various types of concentrations. And you can kind of think of that as like cleaning supplies. How many of you own cleaning supplies at home? You buy like a big, like bulk amount of chemical, but you dilute it with water, right? And it's cheaper, right? It's cheaper to buy like the bulk concentrated cleaning supplies and you dilute it with water at home than it is to like go buy the pre-diluted bottle, right? Does that make sense? Okay, same thing in the world of chemicals. So if we want to dilute something, we use this equation. Please copy it down. So the equation is M1 times V1 equals M2 times V2. Okay. M is the initial molarity. And remember, molarity is just the moles divided by the liters. Do you remember that's what we did in class on Monday? Okay. V is the initial volume. Okay. M2 is that final or like desired molarity that you're looking for. And then V2 is the final volume. Okay. In here, I have volume as liters. It can also be milliliters as long as they both match. Okay. So you can use this equation in liters or milliliters, but V1 and V2 just have to be matching units. Does that make sense? Okay. Okay, we're going to do 2 practice problems. I would say possibly the hardest part of the practice problem is just reading it and figuring out which one's M1, V1, which one's M2 and V2. Okay. So we're going to look at how would you prepare 100 milliliters of 0.40 molar magnesium sulfate from a stock solution of 2.0 molar magnesium sulfate. Okay, so when you look at the word problem, we just have to figure out like which is M1, V1, M2, V2. I typically start with M2, V2. So at the end of the dilution, like what are you actually looking for? Okay. So at the end of this, you want 100 milliliters of 0.40 molar MgSO4. Okay. So that ends up being V2 and M2. Okay. So V2 is 100 milliliters. M2 is 0.40 molar. If you read the word problem, do you see a second volume? There's no second volume, so we're going to end up solving for V1. So I'm just going to put a question mark there. And then what's the other molarity listed? 2.0. Okay. So that's that stock solution, or that's your starting solution. Okay. So what this is saying is you have this 2.0 molar solution, but we have to dilute it down to 0.40 molar. So how do we do that? Okay. So to figure that out, we're going to use M1 V1 equals M2 V2. Okay. So we're going to take 2.0 molar times V1 is going to equal 0.40 molar times 100 milliliters. Okay, so we're going to solve for V1. So how do you get V1 by itself? What are you going to divide by? Okay, so you're going to divide both sides by 2.0. What's 0.4 times 100? 40. What's 40 divided by 2? 20. Okay. And then look at units. So molar cancels. So what's the only unit left over? Okay. So your answer is 20 milliliters, but what does that mean? Okay. This, I think, is kind of the hard part, where now you have to relate this like back to reality. What does that mean? It means you need 20 milliliters of this stock solution. Okay, so this is talking of the MgSO4. So then how do you actually make this solution? And today you're going to make a solution like this in the lab. So how do you actually do it? Okay. So that means you're going to need 20 milliliters of this stock solution, MgSO4. Okay, so 20 mils of this 2 molar MgSO4 plus, what's your total volume of solution you need? 100 mils. So what are you going to mix this with, you think? Say that louder. Good, water. And how many milliliters of water do you need to get to 100? 20 plus 80. Good. Okay. So then you would mix this with 80 milliliters of water. Okay. So when you were to mix the 20 mils of the 2 molar solution with 80 milliliters of water, that's how you're going to end up diluting it down to the 0.40 molar. All right, this time you need 250 milliliters of 0.20 molar NaCl, but the only supply of NaCl you have is 1.0 molar. How much water do you need to dilute the solution from 1 molar to 0.20 molar? Okay, so first, you just need to identify M1, V1, M2, and V2. And which one's easier to start with, the 1s or the 2s? Okay, let's start with the 2s. So what's the final product you want? Good. Okay, so that final molarity, you want it to be the 0.20 molar. And what volume of that do you want? Okay, you want it to be 250 milliliters. Okay. What's your starting molarity? It's the only other molarity number we haven't used, right? So you're going to start with the 1 molar solution. And is there anything in the word problem about a starting volume? No. Okay, so this one just remains our unknown. So that's what we're going to solve for. Okay, so now we'll just plug it into our equation. So M1, V1 equals M2, V2. Okay, and we need to solve for V, so what do you do to get V by itself? Okay, divide both sides by 1. So what's 0.2 times 250? 50? Okay. The M's cancel, so what's the only unit left? Okay. Milliliters. Okay, so we're going to take this one step further. Like, what does that actually mean? How would you make this solution? So you would take 50 milliliters of what? Yep, and it has to be the 1 molar, because that's the one that you actually have. So you're going to take 50 mils of the 1 molar NaCl, and what are you going to add that to? What do you dilute things in? Water. And how much does that final volume have to be? 250. So how much water do you have to dilute that in? Good. Okay, so you're going to mix that with 200 milliliters of water. So if you read this question, it asks, like, what would your actual final answer be for this question if you read what it's asking you for? Good. So this one's specifically asking you how much water. So like this 200 milliliters of water is like the actual answer we're looking for. So in the world of chemistry, okay, and in the world of like a lot of science labs and in industry, molarity is the preferred concentration. Okay, so if we want to know how concentrated a solution is, we look at it in moles per liter. However, the everyday consumer, do you think that they want to see like concentration in moles per liter? Like if you're going to the grocery store and you're buying some cleaning supplies, does the average person want to read that concentration in moles per liter? No. So we're going to learn 2 different ways to express concentrations, and which you're going to see like in the everyday world. Okay, like so when you go grocery shopping, like how do we show concentrations for people who maybe don't love moles? Okay. So one option is to express something by the volume percent. So if you have a liquid dissolved in a liquid, okay, so liquid dissolved in liquid, we do something called percent by volume. Okay, so write this equation down. So just volume of the solute divided by volume of the solution times 100%. For this one, units for volume don't matter as long as they match. Okay, so if the solute's in milliliters, what does the volume of the solution have to be? Milliliters. Okay, if the solute's in liters, what does the solution have to be? Liters. Okay, it's either or, they just have to match. An example of where you see this in real life is like alcohol. How many of you probably have rubbing alcohol at home? Okay, if you look at it, it'll tell you like this one's 99% alcohol. At home, you might have like 70% alcohol. Okay, so like when you go to the grocery store and you buy rubbing alcohol, probably for like your first aid kit, do you want to read molarity of how many moles are in this container? Probably not, right? People want percent, so it's going to be listed in percents. Same thing with like hydrogen peroxide. How many of you have hydrogen peroxide at home? You probably do. Okay. Hydrogen peroxide is usually just 3%. So liquids dissolved in liquids in everyday concentration, we give it to percent-wise. All right, so a solution is prepared by dissolving 60 milliliters of ethanol in enough water to make a total volume of 200 milliliters. What's the percent by volume of ethanol in the solution? Okay, so to find the percent, it's just the volume of the solute. What's the solute in this example, you think? What always does the dissolving? Water. So what's the other substance in here that isn't water? Ethanol. Okay, so that's your solute. So how much ethanol is in this problem? Okay, so 60 milliliters of ethanol. And we're just going to divide it by the total volume of the solution. So what's the total volume? Okay, 200. And then to convert it to a percent, you're just going to multiply that by 100. So 60 divided by 250, and then multiply by 100.
Is it 250 or 200?
Oh, it's 200. I made a mistake. I'm still living on the last problem, I think. Okay, so what's 60 over 200? Point 0.3, and then times that by 100. Good. Okay, so this comes out to 30%. Okay, so this solution is going to be 30% alcohol. So then what's the other 70%? Water. Okay, so it's 30% alcohol, 70% water. Okay. Other times we have substances that are solid that are dissolved in a liquid. How many of you wear contacts? A good example I can think of this is your contact solution. Have you ever read it's like 3% saline? Okay, so saline is another fancy word for salt, okay? So salts are solids. So when we dissolve solids in liquids, they don't have matching units, right? Like solids get measured in grams, liquids are usually liters or milliliters. So you can't just find like a percent, it's percent mass by volume, okay? So do get this equation down also. So it's just the mass of the solute divided by volume of solution times 100. This time, units are important. Okay, so get your units down in your notes. Write it, highlight it, star it, underline it. This time, like when we do practice problems, you do need to match these units. Okay, so you need to be in grams and milliliters. So again, it's like if you're going to the store, and let's say you wear contacts, do you kind of want to know what you're putting in your eyes? Right? Like, do you want to know? Most people don't relate to molarity very well. So if it was like 5 moles of sodium chloride are in the solution, That probably doesn't mean anything to you, but percents do. So like 3% salt, you feel like that's probably fine to put in your eyes, right? Would you want to buy something that's like 98% salt? No. So we do percents. Those are typically more understandable. Are you okay if I change this? Okay. Okay, we're going to do one practice problem. A solution is prepared by dissolving 20 grams of sodium chloride in enough water to make a total volume of 500 milliliters. What's the percent by mass volume of the sodium chloride? Okay, so the percent, it's the mass of the solute. So what's the mass of the solute in this problem? Okay, so it's 20 grams. And it's divided by the volume of the whole solution. What's the volume? Okay, 500 milliliters. And then we just times it by 100. What are we getting? 40. Are you getting 40? Okay. So this one, there's 40% salt in this solution. Are you getting 4?
Yeah.
Y'all have to correct me. I'm making up numbers. Okay, so there's 4% salt in this solution.